Okay, you guys, so yesterday we talked about the idea of multiplicity. Remember, multiplicity being that a zero occurs, the number of times a zero occurs. So if the multiplicity is 2, that means that the zero occurs twice. So in this problem, we are dealing with a 4th degree polynomial. Yesterday we only dealt with 3 degree polynomials. So we are going to have 4 x-intercepts total. Okay, so what's going to happen is I'm telling you that -3 and 3 are zeros. So we are going to have to use synthetic division twice. And we're doing that with 3 and -3 so that I can get down to an x squared polynomial so we can factor it, okay? So, and it doesn't matter which one you try first. They both work because they're both zeros. So I'm just going to go with the first one they gave me. So I'm going to use synthetic division with -3. And I'm going to put 1, -4, -21, 36, and 108 in the house, okay? So I'm going to bring down 1. 1 times -3 is -3, -7, 21, 0, 36, -108, and I got a remainder of 0, which is perfect. That means that it worked. That is an x-intercept, okay? The problem, the reason we have to divide again is because this is an x cubed polynomial. This is really, I'm just going to write it up here. What we have right now is x cubed minus 7x squared plus 36. We don't know how to factor that, you guys. So we have to use synthetic division one more time. So I already used -3, so now I'm going to use +3 next. The only thing you need to remember is that when you use synthetic division again, you're now using it with your new numbers. I'm not using the original, okay? Because I want to make my x cubed, I want to bring it down 1 more degree. So once I divide, I use my new answers for my next part. So 3 is going to go on the outside, and these are the numbers I'm going to put here. Don't forget the 0, your placeholder, because you have 0x, okay? So you're not using the original. I need to bring down the x cubed. So again, I'm going to use synthetic. If you want to pause and try it yourself, please do that. Okay, and I get a remainder of 0, which is perfect. So now I have this polynomial. This is my number term, this is my x, and this is my x squared. Okay, so I have x squared minus 4x minus 12. So now we can factor it. Now that I have an x squared, I'm good to go. So I'm thinking of 2 numbers that multiply to give me -12, add to give me -4. So -6 and +2 work here, okay? So my 4 x-intercepts are 6, -2, +3, and -3. These ones were given to you. These ones you found, okay? None of them repeat. They're 4 x-intercepts. There's no multiplicity of 2 here. So I'm just going to plot them. Here's -3, +3, -2, and 6. I'm going to just pretend, I know this is very off my scale, but I'm going to act like that's 108, okay? So when we graph this, so here are the zeros. The only thing we need when we're talking about graphing is the degree. So we talked about the degree of this polynomial is 4, and it's positive because there's just a +1 in front here. So my end behavior is going to be like this. And because none of these are all odd because they only all occur once. So I'm going to go through the x-axis, go through the x-axis, go through the x-axis, go through. None of them bounce, there are no turning points anywhere, and that is my graph, okay? So in factored form, the way I would write this polynomial is x minus 6, x plus 2, that's what I got here and here once I did the synthetic division, then x plus 3 and x minus 3 from when I was given my zeros, okay? So that's the first one. Then we only have one more to talk about. So in this scenario, they're telling me, again, I have a 4th degree, which means I'm going to have to use synthetic twice, okay? They're telling me -2 is an x-intercept of multiplicity 2. So -2 is an x-intercept twice. So I'm going to use synthetic division twice with the same number. I'm using -2, okay? So what I would suggest is you pause this and try it yourself. In here is going to go 1, 2, -7, -20, -12. I got a remainder of 0, which is perfect, okay? So I'm going to do -2 one more time, but remember, these are the numbers I'm going to use, not this original. I'm using my x cubed numbers. So that's going to go right here. I'm going to go 1, 0, -7, and -6. Okay? So remember, we're doing this twice because now I have an x squared term. Here's my number, here's my x squared, and we know how to factor that. So x squared minus 2x minus 3 equals 0. I'm thinking of two numbers that multiply to give me -3, but that add to give me -2. So remember, -3 plus 1 will work here. So my zeros are x equals 3, x equals -1. I'm getting that from here and from here. And x equals -2. And next to this, I'm going to write with a multiplicity of 2. I'm expecting 4 x-intercepts because my degree is 4. So when that happens, you need to show me, here's 1, here's 2, here's 3 and 4, because this occurs twice, okay? So in factored form, I would write x plus 2 squared, multiplicity of 2. It's occurring twice. It's the same thing as writing x plus 2 times x plus 2. X minus 3 and x plus 1. So there's my factored form. And now let's graph it. If I were you, I would pause the video and graph it on your own. Okay, so my 3x-intercept, or my 4x-intercepts are -1, -2 twice, and 3. My y-intercept is -12. I know that because it's right here. If I make all of these 0, I get -12, okay? My end behavior is even positive because my degree is 4. So I know my end behavior, both my arrows are going up, okay? So at -2, you guys, -2 is going to be my turning point because it has a multiplicity of 2. Remember that turning point or that bounce that we talked about yesterday? So as I come down, I'm going to bounce, go back up. Here's my turning point. I'm going to come through, straight through the y-axis, and straight through again for the end part, okay? So these two I went straight through because they only occurred once. Because this occurred twice, I bounced here, okay? You guys are all set.